Hello and welcome to Easy Maths. In this video, I'm going to focus on additional concepts on chords. And so let's just turn our attention to the day's area. The first one has to do with parallel chords. We're going to say that a perpendicular bisector of all parallel chords is the diameter of the given circle. Now, consider the parallel chords A, B, and PQ. We have the circle there, and then we have the chord AB, and we have the chord PQ. Now, bisector of AB is line NN. See, we have a line NN, which is the bisector of the chord AB. And in the first concept of chords, we said a perpendicular bisector of a chord passes through the center of the circle. That means the line NN must be passing through the center of the circle. Now, NN also bisects PQ because AB is parallel to PQ, and therefore a perpendicular bisector of AB is also a perpendicular bisector of PQ. And NN therefore is a bisector of all chords that are parallel to AB and PQ. And NN also is the diameter of the circle. And that is the concept there. Notice that it's built from the first concept, that a perpendicular bisector of a chord passes through the center of the circle. Therefore, perpendicular bisector of all chords normally that are parallel normally should be the diameter. Moving on to the concept C, equal chords, we say that equal chords obtain equal angles at the center of the given circle. Now consider the equal chords A, B, and PQ. We have the circle there, we have the chord AB and the chord PQ. Now, if O is a circle center, we have an angle at the center subtended by the chord AB. We also have another chord at the another angle at the center subtended by the chord PQ. So we have an angle like that, and we have another angle like that subtended by the two chords AB and PQ respectively. Notice that AO, BO, PO, and QO are all the radius of the circle. That tells us something, that the triangle ABO is congruent, it's similar, and much more, it is equal to the triangle PQO according to the criteria of SSS, that is, three corresponding sides of the triangles ABO and PQO. That is because AO is equals to BO is equals to PO is equals to QO is equals to radius, and yet AB is equals to PQ. And that tells us that, see, because of what we've just said there, the angle A, the angle B, the angle P, and the angle Q, that is this angle, the same as this angle here, and this angle here, and this other one, they are all equal. And that tells us something. The angle AOB must be equal to the angle POQ. So we have two similar triangles, or even like, they are not just similar, they are actually equal. We have two equal triangles. That means we have this angle, since it's equal to this one, it also equals to this other one and the other one there, and that means that this angle also must be equal to the same as that. And that is the concept there. Please look at it this way. We can say that the chords A, B, and PQ are equidistant from the center of the circle also. What's the reason? You see, this perpendicular bisector of the chord AB, this distance here, can be found by just having the square root of r squared minus b to this point squared. Again, we know the distance O to the chord PQ can be found just by having r squared minus, the square root of r squared minus p to this point squared. Please notice that we are saying the distance from r is given by the square root of r squared minus this distance, and yet this distance also the same as the square root of r squared minus p to this point squared, and yet p to this point is the same as b to this point. That tells you something. This distance must be the same as this, and therefore we can say that A, B, and PQ are equal distances for the circle center. Now we can say this statement, say in the opposite way, or just in another way, that if two chords are equal distances from the circle center, then they subtend equal angles at the center of the circle, and they are also equal. And that brings me to the end of that lesson on part D and part C of the concepts of chords. We go on to another one in the next video. Thank you.